we're going to move to PITS project, sorting of plastics. We have here Clara. Clara Stepbrot holds a diploma, sorry if I'm not pronouncing what your surname, holds a diploma in photonics engineering and a master's in entrepreneurship. She founded Plastry in 2019, a company which enabled SMEs sorting centers to reliably identify plastic waste. So I'm not taking more time from you. Your presentation is uploaded to the folder, and I'm going to share it. If you want to start, say something.
Yes, hello to everybody. I will present you the result of the work we've done at Plastry during the INCIRCULAR project, Cascade funding. It is focused on the challenge of identification, because it is the key part in recycling. So first we know the composition of the waste. And our proposal is to be able to well identify the waste before the grinding, to have a high level of purity before processing to recycling.
Your slides ready.
Okay.
I just
have to change here.
Confirm our audience is you can see it, right?
Maybe I stay here, but
yeah.
Because I don't know if you may well otherwise. So that's it. So our technology is made to be set before the grinding and recycling process, to have a high level of purity for our materials. And we were working, of course, with Gorenio samples, but also the aim of the project was to widely open the application field for this technology. So we made some study for also other waste deposits. So just quickly a presentation of the company. So as I say, our mission is to identify the different kind of polymers within the waste. So we have the first product we launched that we see here, which is a handheld device that enables to easily identify the polymer component the waste. And we have this hyperspectral camera, which is the focus subject, let's say, of today. And the aim of the INCIRCULAR project was to raise it at industrial level of maturity, to be able to start selling it to some recycling plants. And also, which is very important, and I will say a few words about it during the presentation, our company is has a large part of its activity focused on research, because in identification there is still a lot of challenges, as in identifying dark materials or complex materials. So it's also a large part of what we do. We are a 6-person team, and we are also working for the research with 12 laboratories of scenarios. So the change of the project is really focused on the identification. Within the recycling chain, the bottleneck is identification, sorry. Today we are able to identify only a few parts of the waste we have to deal with, around 60%. So if we are not able to go further, we will never reach our recycling objectives. So it is very important. And also it's a change which becomes even more urgent, because the recycling chain is start to, let's say, answer to some norms and regulations. So to reach these norms, we need more identification solution. So the challenge, yes, it was to reach mature industrial maturity grade with this hyperspectral identification line. So the main objective to reach this goal is to be able to effectively address various fields of recycling, because it is not the same to identify waste, for example, bedding furniture field, or to automotive, or to appliance waste. All those kind of industry have various needs, and we need to be able to address it. So we developed algorithm for each one of this application. We also made work to improve the camera performances. I have the speed, I have the readability of the results that we are given. And in this part, there was a large part of the work which was co-development. So going to talk with industrial to understand better their needs and see what we are, which part we are able to, let's say, standardize and which part we have to make special to personalize depending on the application. So that's it. The work we performed during this project, so there is a large part of it which is a work of development. So we developed new algorithm for the fabric industry, for the bedding furniture industry, for the appliance waste identification, also for the household identification, but more for an quality sorting, quality control application. We also built a line to, of course, test this algorithm in real conditions. So this line is an important result of INCIRCULAR project because it allows us after to make testing for new prospects, new clients, to show them what we're able to do with their waste deposit. Also, a big result of this project is that we already been able to install line to a first client at the end of the project in January to sort electronic card. So it was to recognize the component and the composition of the board of the electronic card. So this is very good because it shows us that INCIRCULAR project help us to reach our already start to help us reach our market. And yes, a little the last sentence. Also during the project, we made some studies of the ways we can encounter with our new technology we are developing in research about dark materials. So we put also, I don't put here in the presentation, but we put also in the final report some results on black materials because we show we were able to go further than actual solution in the market. So with the thing we developed, we have so 4 new identification algorithms for 4 applications. These applications are not, let's say, choose randomly. It's because we are also some commercial proposal under it. So it is just to explain that this INCIRCULAR project, we use it to be able to know commercialize this solution. We have high level of identification accuracy. We made a lot of training on the algorithm and retest to show the performances of our classification. So now we reach a level of maturity which is enough to start answering needs of clients. And it is the case because, as I say, we already put a first line in production for electronic car. It's better to to see some pictures to understand what we do. So I put some visual. So here you can see some sample of Gorenje and also a sample of a PE bottle. Which what you have here is that you have the object, the curves we are measuring with our camera, and the image in a fake color. So the color is linked to polymer identification. So you see that we are able to see the composition of an entire object. And on the bottle sample, what is interesting is that we are able to see which part is in plastic, which part is in paper. I didn't put it here because it's less easy to, it's less visual, but we also made some tests on flakes, which can be interesting, for example, to see after the sorting, if, for example, a set of PP flakes has the level of purity required for the cleaning. So the main competitive advantage of our solution is to be able to really fit the need of the customer. Because as I say, every kind of waste we have to deal with is different. So we are really work on this by making a personalized algorithm for each kind of waste deposit. And also, during the project, we linked a partnership with a company of robotics, which is also in Saint-Etienne, where we are based, to be able to also propose the sorting part for our partner. So this partner robotics is able to propose various kind of solution for the sorting. It is something really important for the client, because at the end you need a solution which is completely operational. And also, what we are, which is interesting for our clients, is that we are working on the identification of black materials, multi-layers materials, because today it's a big problem in the recycling chain. So this new technology we are developing, in the future, we will be able to put it in this hyperspectral identification line, so to better answer the need of this client. Our business model is to be able to be focused on the customer need. So we are like this, introducing, let's say, ourselves in all the new recycling chain. It's a B2B approach, and the model for this hyperspectral camera is that we are selling it as it is personalized to the industrial site. It's project between 80,000 euros and 200,000 euros, depending on the complexity of what we have to deal with. And for the next year, we are expecting to close 2 projects. It seems realistic, as we already have 4 proposals under, let's say, evaluation. And with the time, we will raise our turnover on this activity by expanding this device. Which is interesting also is that on the 4 proposals we have currently, some of the partners are ambitious to scale their models within other countries of Europe. So it's also interesting. For the project impact, it's really depending on which kind of waste we are recycling, of course. So as an example, the first line, which has, let's say, more maturity, is to recycle shoes. With this line, we are able to take the materials which interest our clients, so TPU, and it's 120 tons of TPU, which are reused every year with this, thanks to this camera. Our perspective, for the hyperspectral camera, as I say, of course, now it's to reach our market. So we are starting to have intense commercial activity to find a prospect and customer for this product, so recycling site. And also, our perspective is really linked to what we will be able to reach as an objective of research, to be able to identify more waste. So we already have good results. We show that we are able to identify materials in depth within a product. For example, if I have 2 layers, we show that we are able to see the composition of the second layer. And also for the black plastic, it's really the thematic of the year. We already show that we are able to go further than the current solution. So this is also very strategic for us to be able tomorrow to identify maybe 80% of the deposit of the waste we are producing. That's it. I have last slide, but it's it's quite short. We were asked to talk about our further needs. So of course, for us, our further need is to be able to still continue to develop our technology. So we are looking for a project and funding for the research. So it's important. It's very important. So that's it.